Have you ever thought about what happens when two opposing forces collide? Well, in 1928, a physicist named Paul Dirac, one of the founding fathers of the new science of quantum mechanics, was attempting to solve an equation that included the implications of the special relativity theory to describe the electron activity in the microscopic realm. Surprisingly, the equation allowed solutions that relate to electrons with negative energy from the past, and thus, antimatter was discovered. But what is antimatter? What can it do? Can it make bombs? Is there a person made of antimatter? This is the story of antimatter. Antimatter is opposite to matter, literally. For every subatomic particle, like a proton, electron, and a neutron, there exists an antiproton, anti-electron, and anti-neutron. The antimatter or antiparticle will have the same mass as a normal particle, but with opposite signs or reverse, mostly negative. Matter and antimatter particles are always produced in pair, and if they come in contact, annihilate one another, leaving behind pure energy. The study of antimatter can also prove to be useful in the medical field. Take the PET scan for example, which is arguably the most common application for antimatter. PET, or positron emission tomography. P stands for positron, which is a subatomic antimatter particle. Medical professionals use positron emission tomography to inject positrons into a brain and watch out for gamma rays that might clash when positrons encounter its counterpart, the electrons. Since antimatter and matter destroy each other when they collide, the positrons emit a light when they collide with the electrons, forming a pattern that is different from a normal brain to a brain with complications, thus finding neurological aberrations. But why do we pursue studying antimatter? Well, we cannot predict what revelations the research on antimatter will result in, but the results may greatly enhance our knowledge of the universe. Let us go back to the Big Bang. It was speculated that in the Big Bang theory, there should have been equal amounts of matter and antimatter. But if that were the case, the universe we know as it is today shall cease to exist, since a collision of both forces will result to annihilation. But why did the Big Bang produce more matter than antimatter? No one knows. This stands as one of the greatest mysteries of physics ever known to man.